Now your exit ticket out of this section is helping to understand if we can look at expressions, but this one wants an equation, are there particular values of x that make this true? So we're going to use all the skills we've learned so far to look at an equation and discover, is -3 a solution to this particular equation? So remember kind of how we do that? Well, first of all, let's write the equation. Then everywhere there's an x, we put in its value. Now I want you to take very close note to a couple things I did that you need to do every single time. Notice that I substitute the value in the -3 for every x. And the way that helped me do that is I put parentheses around that value. Here, if I was lazy, I may have just put in, there's already a negative. Maybe I would have forgot the negative that goes with the 3. And there my values would have been off. So a good practice is when you're looking at an original equation, put parentheses around the values of the x's that you're replacing. From there, let's see what we can solve. I can do a multiplication problem on this side because our process is multiplication first, unless there's any summations within parentheses. There are no summations within parentheses. Although there's parentheses, there's no work happening within those parentheses. 6 times a -3, positive times a negative, plus a 14, equals a -7. We can change it to adding its opposite. So this becomes plus the opposite of -3, which is a 3. -18 plus 14. The -18 is larger than the 14, so my value is going to remain as a 4, but it's going to be a -4. And then likewise over here, -7 plus a 3 produces a -4. So in this particular case, the value of x that would make this true was indeed a -3, because I got a true statement after reducing and simplifying it on down.